Your brake calipers are seizing right now, locking up, dragging, heating your rotors until they glow, and the repair industry wants you terrified before you even understand what is actually failing. They tell you the metal caliper is destroyed. They tell you the whole braking assembly has to come apart. They slide an $800 estimate across the counter as if catastrophe is already inside your wheels. But the truth is far smaller than that, and far more infuriating. Because the failure they are selling as mechanical death often begins with something almost invisible. 2 steel slide pins, 2 small rubber boots, a smear of the wrong grease. That is where the trap starts. But the reality is, once that chemical mistake is made, the rest of the disaster unfolds with brutal predictability. Your brake caliper slides on 2 precision steel pins. Those pins are protected by small EPDM rubber boots. On paper, that sounds like a durable, well-engineered system. And in some ways it is. EPDM handles heat well. It handles water well. It handles ultraviolet exposure well. But it has one major weakness, and that weakness is petroleum. Standard petroleum-based grease attacks EPDM at the molecular level. The rubber absorbs those hydrocarbon molecules like a sponge. It swells, it softens, it tears. Then the seal fails. And once that seal fails, water and road salt do what they always do. They rush in. They sit on bare metal. Corrosion starts fast. The slide pins begin to rust. And rust does not just discolor steel. It expands. It wedges itself into the pin bore and locks the mechanism solid. Now the caliper cannot release cleanly. The brake pad drags against the rotor non-stop. Heat builds. Fuel economy drops by 20%. The steering starts to feel wrong. The car feels heavy. The rotors overheat. Sometimes they warp. Sometimes they distort so badly that the whole system feels like it is shaking itself apart. Then comes the moment they are counting on. You drive in worried, and they point dramatically at the hot rotor, the worn pads, the ugly corrosion, and they tell you the caliper is finished. They quote $800 per axle. They charge labor at $150 per hour. They turn a tiny chemical compatibility failure into a full mechanical replacement job. And really, that is the core of the scam. Not that brake systems can fail. They can. Not that seized pins are dangerous. They are. The problem is that the diagnosis jumps straight past the root cause and lands on the most profitable possible repair. Because the cast metal caliper body is often not the part that died. The hydraulic assembly is often not the true problem. What jammed was a steel pin sitting inside a failed rubber seal. What triggered the failure was the wrong lubricant. That is the whole chain. Simple, dirty, expensive, only because someone decided it should be. Now here is where the story turns. Because the fix they never want emphasized is not exotic. It is not hidden in a dealership vault. It is not some proprietary compound controlled by a parts department. It is pure silicone paste. A $3 tube. Plumbing aisle. Automotive aisle. Hardware store shelf. That is the compound that changes everything. Silicone does what petroleum grease cannot do. It lubricates without chemically attacking EPDM. It creates a water-resistant barrier. It remains stable in extreme temperatures. But what is especially striking is that this is not some fringe garage myth. The science behind it is older, tougher, and more battle-tested than the modern brake service industry wants to admit. Back in the early 1960s, aerospace engineers were dealing with rubber seal failures under conditions more violent than anything your daily driver will ever see. Standard petroleum lubricants froze under extreme cold. They burned off under intense heat. They failed under vacuum and brutal atmospheric stress. Engineers needed something that would not degrade rubber, would not melt away, and would not collapse when everything else did. What they found was polydimethylsiloxane, pure silicone compound. That discovery mattered. They coated critical rubber seals with silicone, and the results were extraordinary. Temperatures from -100 to +600 degrees Fahrenheit did not break it down. It did not melt. It did not attack the rubber beneath it. It remained stable across violent thermal swings that would destroy ordinary lubricants. That same chemistry later proved itself in deep-sea military submarines and in nuclear facilities, where rubber junctions and seals could not be allowed to fail casually. In those worlds, material compatibility was not a suggestion. It was survival. And yet somehow, in the everyday automotive world, the superior protocol disappeared behind cheap grease and expensive repairs. That is the detail worth sitting with. Because really, once you know the chemistry, the pattern becomes hard to ignore. A permanent or long-lasting rubber-safe lubricant threatens a repair model built on recurring corrosion, recurring seizure, and recurring parts replacement. A $3 solution does not keep a bloated service structure fed. An $800 panic repair does. So the cycle continues. Petroleum grease goes on. EPDM boots swell. The rubber tears, water gets in. Rust locks the pins, pads drag, rotors overheat. Drivers get scared, bills get printed, and the original chemical mistake is buried under the language of total component failure. That is how a tiny compatibility issue turns into a repeating revenue stream. But the truth has not changed. The right silicone chemistry was already proven in the harshest environments imaginable decades ago. It was proven where failure was unacceptable, proven where heat, pressure, cold, and exposure would destroy anything mediocre. And that is why this matters so much. Because the same kind of material logic that protected critical seals in aerospace can protect the humble slide pins on your brake calipers. The science is not mysterious. The deception is. The metal hardware did not suddenly become cursed. The system did not fail by magic. A rubber boot met the wrong grease. The seal broke down, corrosion moved in, and the repair bill grew fat on top of that chain reaction. That is the opening act. That is where the damage begins. And once you understand that, the rest of the brake caliper story starts looking a lot less like inevitable wear and a lot more like preventable failure sold at premium price. To understand why this failure becomes so destructive, you have to look past the repair counter language and into the actual mechanics of a disc brake. The system is simple, but the conditions are brutal. A heavy metal caliper clamps brake pads against a spinning rotor every time you press the pedal. Then, the moment you lift your foot, that caliper must release cleanly. It does not do that by magic. It does it by sliding freely on two steel pins. Those two pins are the mechanical heart of the entire braking system, but the reality is, they live in one of the most hostile environments on the vehicle. Water, mud, road salt, heat, repeated friction cycles, constant thermal shock. That is what those pins face every day. Engineers knew that, which is why they used EPDM rubber boots to seal them off from the outside world. EPDM is not weak material. In fact, it is extraordinarily resistant to heat, water, and ultraviolet radiation. Under the right conditions, it does its job very well. But under the wrong chemical conditions, the whole design collapses. And that wrong chemical condition is petroleum-based grease. The moment standard black grease touches an EPDM rubber boot, the molecular damage begins. Petroleum hydrocarbons do not just sit harmlessly on the surface. They invade the polymer structure of the rubber. The boot absorbs the oil, it swells, it softens, its dimensions change. What was once a tight sealing barrier becomes bloated and unstable. But what is especially important is that this is not cosmetic damage. This is structural collapse. The boot tears. The seal opens. Protection is gone. Once that happens, the exposed steel pin is no longer isolated. Rainwater enters. Road salt enters. Moisture sits where it should never be allowed to sit. Oxidation begins immediately. Rust starts building on the pin and inside the bore. And rust does not stay politely in place. It expands physically as it forms. That expansion wedges the steel tighter and tighter until the slide pin no longer moves the way it was engineered to move. Sometimes it becomes stiff. Sometimes it binds. Sometimes it locks completely solid. The instant that pin stops sliding freely, the caliper cannot release properly. That is where the real trouble begins. The brake pad remains in contact with the rotor while the wheel is spinning. Not for a second, not for a single stop, continuously. Every mile, every turn, every minute you drive, friction is still being generated. Heat rises relentlessly. Rotor temperatures can climb above 1,000 degrees Fahrenheit under sustained drag. At that point, the braking system is no longer just inefficient. It is cooking itself alive. The rotor can warp, the pad can glaze. Fuel economy can collapse because the drivetrain is now dragging a partially applied brake. Steering wheel vibration begins. The car feels sluggish. The wheel may radiate abnormal heat after a short drive, and when a mechanic sees that mess later, the visual evidence looks dramatic enough to justify a dramatic price. But really, the cast iron caliper itself may still be perfectly fine. The hydraulic body may still be fully usable. The root failure was a rusted precision pin trapped in a chemically destroyed sealing system. That distinction matters. It matters because it separates an actual hydraulic failure from a serviceable slide mechanism problem. And that is exactly where pure silicone paste changes the equation. Pure silicone paste is a fully synthetic, chemically inert compound. It contains no hydrocarbon chains that attack EPDM rubber. When silicone contacts the rubber boot, nothing destructive happens. No swelling, no chemical invasion, no hidden breakdown waiting until the 36-month mark. Instead, the silicone preserves the rubber surface and maintains flexibility. It lubricates the metal pin while leaving the seal itself chemically unharmed. That is the key difference. That is why one grease creates failure and the other prevents it. But the effect does not stop at chemical compatibility. Silicone also forms a hydrophobic barrier. Water molecules cannot bond to the coated surface the same way they do on untreated or poorly protected metal. Moisture rolls off. It does not settle in. It does not stay long enough to start the oxidation cycle that locks the pin. The slide pin remains dry, the bore remains cleaner. The caliper continues to move the way it was designed to move. Temperature stability is another part of this story. Pure silicone maintains protective performance from -40 to +600 degrees Fahrenheit. It does not melt away under heavy braking. It does not wash out easily. It does not break down the moment the system gets hot. That means the lubrication remains where it needs to remain, exactly when cheaper compounds begin to fail. So after each stop, the caliper slides back cleanly, the pads release, the rotor turns freely, heat drops to normal operating levels instead of building into a destructive cycle. This is why the benefits show up immediately once the root issue is properly addressed. Brake drag disappears, rotor protection improves. Fuel economy recovers because the drivetrain is no longer fighting constant friction. Steering vibration often stops because the rotor is no longer being tortured by continuous contact. The first drive after a proper slide pin service can feel radically different, not because of some miracle, but because the brake system has finally been allowed to return to its intended geometry and motion. And then the financial insult comes into focus. A dealership-style caliper replacement can cost $800 per axle. If the underlying chemical cause is never corrected, the same corrosion cycle can come back within 36 months. Over a 12-year ownership period, that can mean $3,200 surrendered just to repeating slide pin-related failures. That number does not even include the $150 diagnostic fee they charge before doing meaningful work. It does not include rotor replacement bundled into the job. It does not include the fear tax built into every service recommendation. Now compare that with the actual chemistry-based solution. A tube of pure silicone paste costs $3. Brake cleaner to prep the pins costs $5. Total material cost for a complete four-wheel brake protection service is $8. $8 against $800. But what makes that comparison so infuriating is not just the price gap. It is the fact that the cheaper fix addresses the root cause while the expensive repair often does not. That is why this feels less like maintenance and more like engineered ignorance. The repair economy depends on most drivers never learning the difference between a seized slide pin and a dead caliper body. It depends on chemical illiteracy. It depends on panic. Because once you understand the physics, the narrative starts breaking apart. You are not looking at an unavoidable collapse of your braking system. You are looking at a preventable failure chain that starts with rubber compatibility, moisture intrusion, and corrosion. And that is the turning point in this story. Not the sale, not the diagnosis, not the invoice. The turning point is when you realize the entire crisis inside that wheel can begin with the wrong grease touching the wrong rubber. Everything after that is consequence. Consequence sold as complexity. Consequence sold as mechanical doom. Consequence sold at premium labor rates. But the actual science is plain. And really, once you see it clearly, the fear starts losing its grip. Now comes the part they never want explained clearly. Not the fear, not the invoice. The actual procedure. The direct fix. The simple, mechanical, brutally inexpensive process that takes this problem out of the hands of service advisors and puts it back where it belongs, inside basic chemistry and careful labor. But the truth is, once you see the steps laid out plainly, the entire $800 narrative starts to look absurd. First, the materials. Pure silicone paste, brake cleaner spray, safety glasses, thick rubber gloves. That is the foundation. The silicone label must say 100% silicone, with no petroleum additives listed. That detail matters. A wrong product puts you right back into the same destructive cycle. A correct product changes everything. Start with one wheel. Loosen the lug nuts before jacking the vehicle. Then raise the vehicle and support it firmly on a quality jack stand. Never trust a hydraulic jack alone. That is not caution theater. That is survival. Once the vehicle is stable, remove the lug nuts completely and pull the wheel off the hub. Now the brake assembly is exposed, and what looked like a mysterious sealed system suddenly becomes very simple. On the back of the caliper bracket, locate the 2 caliper slide bolts. Use the correct size socket and remove both bolts completely. Lift the caliper off the rotor carefully. Do not let it hang by the rubber brake hose. Ever. Suspend it with a wire hook. Because really, if that hose is strained or cracked internally, you have now created a far more serious brake problem than the one you started with. With the caliper supported, locate the rubber boots covering the ends of the slide pins. Pull the pins out of the bracket housing by hand. This is the moment the story becomes visible. If the system has been failing the way described, you will often find corrosion, dried contamination, sticky movement, or boots that are swollen, torn, softened, or misshapen. That is the evidence. That is